Two things just to note before we get started. My name is David Gay. I am from Prairie. I am a client engagement manager. I'm just kicking off as a moderator during the presentation. At that, I'm going to pass off to Travis, and you can get started. Thanks.
All right. Thank you so much, David, for giving me the opportunity to speak with you here today. We'll go ahead and get started. A brief rundown of the agenda. Today, I will be giving you an introduction, followed by a Roto-Molded process evaluation case study. From there, I'll move on to a brief deep dive assembly cost analysis that we recently performed, and from there, we'll do our wrap up. Moving into our introduction and overview. Again, my name is Travis Ohms. I'm an engineering manager for the CNHi mid-range functional team based out of Davenport, Iowa. So effectively what that means as a functional team manager, I'm responsible for the design of all components that touch crop within the mid-range combine, as you can see here on the bottom right. I've been with CNH for 9 years. I started my career as a design engineer specializing in threshing systems for the mid-range combine. I also have experience as a designer for the corn and draper header platforms, along with the advanced combine development team, which all led me to my current role as a manager. So not only am I an engineer, but I'm also an end user of our product. We utilize the mid-range combine on our family farm, so I take a great pride in the product that I produce. I'll expand it out a little bit more to our Harvesting Global product line. We are consisted of the Case IH and New Holland brands. Again, we have the combines and header platforms. Also, we have cotton pickers, sugarcane harvesters, and grape and olive harvesters. So we have a wide variety of equipment to serve our customers, and engineering, design, and manufacturing facilities located throughout the world to serve our customers' needs. A general overview of the program being used with CNH. Our initial training for the harvesting platform took place in early March of 2020, so right as we were heading into our quarantine and lockdowns. The majority of the components processed by my team are sheet metal and weldments. The program has also been utilized though for castings, machine components, roto-molded and injection components, and large assembly roll-ups. Just a few examples you see on the right-hand side of the page that we've utilized the program for. One being a transmission shift fork casting, where we made slight improvements to based off our current product improvement initiative. We were able to cost the changes and align that with our supplier's quotes. The next one down is a formed and welded sheet metal motor mounting assembly. And at the bottom, we have a roto-molded air inlet design that I'll be speaking to on the upcoming slides. So this program allows for instant cost feedback on revisions and new components. So this will reduce our unnecessary loops between the engineer and the cost analysis team, which will lead to an overall reduction in the amount of hours invested in the design phase. This helps, or moving on from there, it also provides manufacturing insight to design engineers and aids in catching potential manufacturing issues. This helps to eliminate the knowledge gap between the design engineers and manufacturing. By utilizing the program, unnecessary loops can be prevented for prototype creation, and the intention is to prevent a design that cannot be produced from ever leaving the designer's desk to begin with. One example I always like to give is, especially since we work primarily with sheet metal components, is the formed legs of the sheet metal components. We'll quickly be able to process it and understand, are we able to bend this component, or is it going to require hard tooling? What improvements can we be made along the way? And finally, and maybe most importantly, the suppliers can be challenged to provide cost alignment. Gaining the knowledge of each individual cost driver allows us to know where either we or our suppliers are falling short and can request justification to go along with their quotes. So moving on, we'll go ahead and step into our Roto-Molded process evaluation study, which we just recently completed. This was done as part of a current product improvement project. It was initiated through our mid-range combine current product improvement team in Sorocaba, Brazil. It's comparable to a current production roto-molded component for our flagship combine team. As you can see on the right-hand side, we have a highly featured baseline component to use as a reference. The goal was to ensure that the cost of our new design for the mid-range combine platform was comparable to that of the flagship platform. So we'll go ahead and take a look at our baseline evaluation. The production component was evaluated a priori to understand the cost differentiation between the software and the real world. Having that baseline is an excellent resource to ensure we are remaining grounded and have not made any bad assumptions along the way. So as you can see here, we were able to generate an estimated cost using a priori of $26.63 versus the actual cost of $25.26. So from there, we had a reasonable margin of error, and we're able to move on from there with confidence. Moving on, we were able to move on from there and generate a new design with that baseline in mind. As the design progressed, multiple iterations were provided from the designer in Brazil to understand the impact of adding the individual features to the design. The goal was to provide instant feedback to that designer on his changes and to understand right out of the gate if this was even a feasible approach he was taking. So also processing these iterations also served as an alternate check, as we said in our overview, for manufacturability of the component. Most importantly with this roto-molded design was the capability to mold it, capability to release it from the mold, and so on. So we call it iterations, but we were actually given 4 designs all concurrently due to the designer's location in Brazil relative to mine in Mount Joy. So we started with a simplified iteration, as you see in number 2. Number 1 and number 3 had additional pockets added at the rear of it. And number 3 and number 4 had an additional pocket on the side of it. So we were able to take those iterations and quickly process them for that engineer. So let's go ahead and step through the breakdown of these proposals. With all things being equal, including annual volume, expected years, and amortized schedule, as you would expect, as we said, the proposal 2 is the most favorable based off the amount of features. But the knowledge we really gained by doing this is that knowing that the additional features that we're not driving a large cost impact, the delta you can see between the 3 was all less than $1, given those differences. So using the costing information generated from the initial iterations, the engineer was able to confidently make updates to the model that could include additional features to accommodate mating components without driving large cost increases. As you can see on the right-hand side, the engineer was able to come up with a streamlined design, capturing additional mounting features, which will ultimately lead to a reduced amount of components at the next assembly level for a cost of $22.30 US. Using the a priori on a highly featured parts is very helpful in proactive part cost management and educating engineers about cost drivers within their designs. So as you can see, our breakout here on this particular component, we had 198 individual cost drivers within this component. An engineer can evaluate where the cost is buried and make changes as required. Not only that, more importantly, they're gaining future knowledge. As they are designing, they will understand in their heads that what needs to be done proactively on those future components to avoid that cost. So we'll go ahead and do a final cost summary based off of that quick evaluation. As we see down here, we had our reference production part estimation. That was the component that we currently produce for our flagship combine. Our estimation showed $26.63. That was based off a current cost comparison of $25.26. As we said, we were within margin of error. From there, we stepped into our initial proposal, simplified proposal. which produced a cost of $21.13. And from there, we were able to move on to our streamlined production intent design, which included additional features for only $22.30. So in summary, using the a priori along with the known baseline component allowed for a confident cost evaluation of the new design. The engineer was able to incorporate the added features he wanted while maintaining his cost targets. So another important point, aligning these cost targets during the initial design phase rather than after the design is completed or possibly tested greatly reduces the risk of circling back to redesign. Being part of a harvesting team, the window for testing can often be narrow. When farmers are ready to harvest, the design needs to be in place. Engineers must provide designs with their best foot forward to ensure it's correct the first pass, because you may not get a second chance. Typically, the mindset has always been functional. Now we can proactively be conscious of that financial impact as well. From here, I'm going to step into a brief deep dive assembly cost analysis that we performed with our New Holland team. So again, this deep dive assembly cost analysis was performed on a header reel assembly, which you can see in the upper right-hand corner. It's a very large and complex design. It's done based out of our New Holland, Pennsylvania facility. So the evaluation was done on 104 unique part numbers. 38 of those were level 1 assemblies and components. That includes a mix of weld assemblies, molded components, hardware, and various sheet metal processes. Completing the deep dive analysis allows for a relative cost comparison to our quoted cost. With this, we were able to generate an 8% differential. We were short 8% versus the quoted cost. But from there, we're able to make evaluations on our end, particularly which components have room for improvement. Can the design, and namely, can the design be improved on our side to reduce that cost? But also, is that quoted price disproportionate to the expectation? Back to our first slide, or back to our overview, can we go out there and challenge those suppliers on those given costs? Another aspect we come across are parts missing that crucial criteria. And part of that we feel is due to legacy carryover parts requiring updating to include appropriate parameters to provide more reliable cost roll-ups in the future. An example of that is the weld being generated. Our previous Creo parts did not generate a weld parameter. Our new ones do. Is the mass being appropriately applied? Is it coming in kilograms versus pounds, et cetera? And the annual volumes, are they being correctly calculated? So from there, alternative digital factories can be reviewed to evaluate the feasibility of moving assemblies or components in-house. And it's all about where do we see that greatest opportunity to increase our margin. So on this deep dive assembly cost analysis, there are some next steps we want to get into, or the team wanted to get into. Of course, it's closing those final gaps and estimations. We need to go through, review those legacy components one by one, and update as necessary. Again, checking those weld assemblies, making sure we have parameters that are driving correctly, verifying hardware, ensuring that we're pulling the correct piece of hardware we like, not a family table, for example. And then understanding that true volume for components used across multiple assemblies. And a great example of that is our fingers on the reel tines. We have, just in this assembly alone, we have 119 reel tines. So that's one assembly on one width variation on one header platform. So obviously there's going to be several of these used across the world. So we need to understand what that true volume actually is. And moving on from there, benchmarking versus our internal digital factories. Should this be a supplied component or assembly, or is it feasible to manufacture in-house? Which internal manufacturing location provides the greatest opportunity for cost reduction? Well, just as an example, given our the delta between our digital factory 1 and our Digital Factory 2, we saw an estimated difference of $1,207 per assembly. Annualized product cost avoidance could be in excess of $2.1 million. So there's great opportunities for improvement based off those numbers. And just as an example, with this deep dive analysis, with the 104 unique components and the large assembly that it was, the engineering time invested to derive the digital factory comparisons was roughly 60 hours. But 60 hours compared to the cost avoidance is well worth it. So just a quick wrap up and some next steps that we're looking forward to in our mid-range and global product lines. For the mid-range combine platform, currently we've been using this to supplement our current product improvement projects. As we shift to the future, we do look to incorporate this in as a standard for our product development applications where feasible. That means encouraging all designers to utilize the program during that part development. It allows for quick BOM cost roll-ups to evaluate the feasibility of design, project, or program. And from there, our business case can be made with confidence and in a much more timely manner than it is today. So appropriate manufacturing locations are also a piece of that. They can be selected utilizing the digital factories within the a priori software. And expanding it out from there, driving our continuous improvement toward the world-class engineering vision. We want production intent, right first time designs. That means we want the features done correctly the first time. We want the cost done correctly the first time, the weight done correctly the first time. All these aspects need to be put together so we have a product that we are proud of the first pass. And part of that is the knowledge management, continuing the journey of cost driver knowledge and competency growth among our people. Engineers need to have an intimate knowledge of the parts they are designing, and we want the knowledge to be ingrained within them so they're contributing to benefit the scope of the overall program and overall team on a daily basis. And from there, our should cost analysis. We need to continue our journey to better equip our buyers to discuss technical aspects of design for manufacturing and assembly with our supply chain partners to realize more win-win scenarios. That means where can we do better and where can they do better to align on the most favorable cost. And by having these breakouts, reports generated from our a priori software, we should be able to engage our buyers with more appropriate information to go out there and make better decisions along the way. So from there, that was my presentation. I thank you for taking the time to listen. It's been a privilege to speak with you today, and I'll pass it back to David.
Awesome. Yeah, thanks, Travis. Great job. So just a few questions for you. I know we have a few minutes here. The first question that I saw is, what percentage of the engineers are using a priori, and then what challenges have you seen when using the tool? I guess you can speak about the team that you work with and understanding some of those challenges and what percent you're seeing today.
Yeah, so as I said, we were rolled out the software heading into the pandemic. So right as the shutdown started to occur, at this point, I'd say roughly 50% of our office is using it. Challenges so far, just like any other engineering program, picking up. Once you get rolling, it's very intuitive, but just knowing where to start was the initial challenge.
Okay, great. The second question, have you had any successes using the virtual factory function to outsource and insource parts? Is one of the questions that was out there.
Yes, we've actually been utilizing this for footprint evaluation, understanding where particular components should be made. And that means maybe it's being shifted from one facility within CNH to another facility where we have a great opportunity. On that last slide I shared, just that one assembly there, you saw there was a delta of $1,207 between the two. So there's great potential there. But yes, opportunities to outsource, opportunities to insource, there's a great deal we can learn from it and a lot more left to learn.
Awesome. And one last question I have here is, do you need CAD models for cost assessments? And I guess from the operator standpoint, I can answer that as you don't have to have CAD models. We have some user guided capabilities as well as 3D modeling. But Travis, do you want to talk about how you're using it today?
Yeah. So as an engineer, design-based engineer, all of our models are going in as 3D CAD models. It's actually simpler for us, and it may be simpler for other folks to take an alternative route, but for us, it's easier to design what we give an initial iteration, as you saw through some of that PowerPoint, and generate our cost based off that, then go back, make the modifications easily, and generate a new cost quickly.
Okay, and then there was one last one that came in. Sorry, Travis,
No problem.
I didn't get to the last one. So the last one we have here, it looks like the question is, what baseline analysis were done with the out of the box settings, and then have we customized, or do we use lower volume or high volume material costs? So I think I can answer that partially. Working with your team and how we've done it, we've done some customizations around many different settings. I think if you look specifically today using high volume, I know we can get back to you. I think Joe, you asked that question, and get back to you and maybe connect you to the team within CNH to just further detail you look for. I don't know, Travis, if you have anything else you want to talk through today. I don't want to go into too much detail because I know it's somewhat custom to you.
Yeah, as far as volumes, yeah, we try and be as accurate as we can based off given components and estimated outputs. That's typically what we're entering into our software, but we do have our digital factories based off of the CNH factories or CNH parameters that do give us more localized feedback to what we were expecting.
Okay, so I think that's the last question. So if anyone has any questions going forward, feel free to contact myself, contact Travis, and I believe if you have any other questions, you can continue to use the Cost Insight chat that we have going, as well as the main page. So if there's anything I see, Travis, that you don't see, I'll reach out to you, and then hopefully people can reach out to you as well.
Perfect.
So thank you so much, and yeah, hope everyone has a great day today. Thanks. Bye.
Thank you.